Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 1091, shortest path in binary matrix. This is a medium level difficulty graph problem, and we're told that we're given an n by n binary matrix called grid, and we need to return the length of the shortest clear path in the matrix. And we're told that a clear path is a matrix from the top left cell, so 0, 0, and the bottom right cell, so n minus 1 and n minus 1, where obviously n is the number of rows and columns in our grid. And we're told that we can visit this clear path can be connected 8 directionally, so we can move we can go from each cell, not just 4 directionally, but 8 directionally. So top right, bottom left, top right, top left, bottom right, bottom left. So in this example, we've got a 0, and the bottom right hand node is 0 as well, and it takes 2. It takes the distance is 2 because it takes 2 cells, or the path distance is 2, so it takes 2 cells to get to the end. In this example, we return 4 because we have 1, 2, 3, and then 4. So that's the output for how long it takes to get to the rightmost, the bottom right cell, basically. And we're also given some constraints. So how do we solve this problem? Well, as you would imagine, we can use breadth first search. And an optimized way to do this would be using like Dijkstra's algorithm. Dijkstra's algorithm is quite similar to BFS anyway, but the naive approach is to use BFS. So let's actually do that. Let's solve this using breadth first search. So the first thing that I like to do is get the number of rows and columns, so the length of the grid and the length of the grid, or the first row in the grid, which is going to give us the number of columns. And what we're going to say is if grid 0, 0 is equal to 1, or grid rows minus 1, columns minus 1 is equal to 1. So if either the top left cell or the bottom right cell are basically 1, so that we know that they're not clear, though we know we can't make a clear path, so then we're just going to return minus 1 by default. Otherwise, let's actually do breadth first search. So let's set our queue equal to a queue of tuples, and the first thing is going to be the row, so we're going to have row which is 0, 0, and then the initial distance is going to be equal to 1. And then we want to get our directions. So our directions is going to be, this is a bit tricky, but it's basically going to be top, let's get this right, top right and top left, and then bottom. So bottom, well actually no, minus 1, 0, and then we're going to do bottom right and bottom left, and then all we have to do is right, so it's going to be right, and then we need to do left. So now we have all 8 directions for our breadth first search. So that's done, and now we don't want to keep have a loop with our grid. When we come across a cell, we want to mark it as visited. So we're going to have a visited set, and we're going to set this. This is where we're going to store the our visited cells. And now let's actually go through our queue. So we're going to say while queue is not empty, let's say RC and distance is going to be equal to q dot pop 0, and if the row and column, so if RC is equal to rows minus 1 and columns minus 1, we know that we have found the bottom right hand cell. We've come to it. So here we can return our distance. Otherwise, we need to go through each direction. So we're going to say for R1, for R2, and we can say C2 in distances, or in directions, sorry, in directions, let's get our new row and column. So we're going to say new row is going to be equal to row plus row 2, and new column is going to be equal to column plus C2. Let's get that correct. And now what we want to do is we want to say, let's check, is this new row and column, are we in bounds? Is it a clear cell? And have we not visited it before? And then we can add it we can add the cell to our queue. So we want to say if the new row is greater than or equal to 0, so is it greater than or equal to 0? And new cell is also greater or equal to 0. And row is less than rows, and C is less than columns, and new C is not in our visited set, okay? And also if the cell is not, is a clear cell. So if clear new C is equal to 0, then we can carry on with our code, and we can say, let's add to our queue dot append row column, or new row new column, and add distance plus 1. And then we can also add to our visited set, visited dot add, and add our new row and new column. So that's our breadth first search code done. And then remember again, if we don't find a path, well, then we just return -1. So let's run our code. Let's check we pass the test cases. And we get a error because list.append. Okay, so we need to append a tuple. So let's run our code again. Dun, dun, dun. And list index out of range. Okay, let's check this again. So new row is greater than or equal to 0. New C is greater than or equal to 0. Okay, we're doing R. So we need to do new row is less than row, and new column is less than columns. Let's check our code passes, and we pass the 3 sample test cases. Let's check our submission passes all the test cases for this problem, and it does. So I hope that made sense. It is a bit of a complicated problem, but once you realize that this is a graph and BFS problem, it becomes a tad bit easier. So in terms of time complexity, well, we have an O of n by n grid, so it's going to be an O of n squared time complexity, and the same is going to be for the space complexity, because worst case scenario, we could have every cell in our grid in our queue. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.